Koiro presents The Only Thing I Have That Doesn't Suck is the Vacuum Cleaner. And as you can see, the spring has finally arrived in the city of Sortland. This, what you see here, is a vacuum cleaner. It's a vacuum cleaner of the kind where you put this in your basement and you have the hose and the outlets around your home. And this is a 1700 watts rated unit. It's quite old, and I do actually had this in for repair a bit earlier, and I was not able to fix it at the first attempt. We will zoom in a bit and I show you what we got here. Yeah, but I think this will be clear enough. What you do have here is a motor. You have a manual power button, and that's overriding this relay down here. You have a power inlet. You have some kind of a fuse here. You do have some kind of a filter thingy down here. Maybe it's a motor capacitor and not a filter. I've not looked into that. And you do have this small control board here. It's not really fitted as it should now, so I will probably be able to pull it out. And this contains a transformer, a control cord and a relay. And the symptom of this is that the motor is not running properly and we get a spark on the relay. And the normal thing to think that is that the relay is not drawing the contacts close enough together, and that might be caused by a too low voltage down here. And this power override button is not controlling the relay, as you remember. It's just short out here over the output of the relay, so that the relay contacts will be bypassed. So that's these leads here. The two black one, the one here black. Let's see how the power goes. The power goes down here into this box, and you have the power out from this box is this white one and black one here. Yeah, he has labeled them, the owner has labeled this 1 and 2. Yeah, and 4 on this. So these, we should be able to take them out. But the motor is this 4, and it's this one here, and this is probably just connected together. So these power lines are connected together, and this one here is switched, the black one. So, what are we going to do? What we first need to do is that we need to establish what kind of voltage actually is on the relay when it's drawn. And then we do have to couple. We see here the power in is on these two. So I do have to take this out. Just disconnect here like so. And I do have to apply power over these two, the 1 and 2. This one actually has 2 here. And see what I get out of the transformer. This one I can remove. And this control board, the last time I did this, I actually did fix a fault. I changed this capacitor and this capacitor. This was totally, dried out. And this one, I don't remember if that was bad too, but I changed both of them. I have measured out all the diodes, the resistors, the resistor networks, and I also done a basic check on these transistors. So on this board then, we actually have only the transformer as our main culprit here. Yeah, we can see this sprint is marked 15 amps, 50 hertz. 1.5 horsepower. It's made by Alutron in Canada. Yeah, and it's marked here motor, L1, L2, motor, earth. So we should be able to measure this out, but we do have to apply 230 volt on these two, so we might need to be careful. So I move this now over to the bench. Yeah, just a short notice here. I had this vacuum cleaner. Actually, this is the first time I have the whole vacuum cleaner into my shop. I did have the card 2 times. The first time I ordered and changed the relay, and only that. And the next time I actually, the owner tested this relay, and the new relay had got somewhat the same fault as the old one, and that is that the relay was starting arcing, so the pads was probably not pushed enough together. And when this arcing starts, the thin plastic that is inside the relay and kind of is the lever that pushes the contact points together is melting. So the pressure to keep these contacts together is getting less and less after this plastic melts, and in the end the solenoid is not able to push the contacts enough together. And the second time I did a more throughout fault finding just on the card, but I did not change the relay. And I was measuring it, and it kind of got okay contact, and I cleaned the contact points. But probably this plastic was already starting melting then. And I also changed some other components, and I filmed that and planned to make a video, but I never did. So that's what I'm going to push you through now. It's something that I meant to put out as a short video, but I never did. And that is the second time I had this board and did this fault finding very quickly, dirty, just change component kind of fault finding. So that's what you're going to see now before I take the card on the bench and do the measurements that I spoke about in the first part of this video. Yes, sometimes you have to do the more mundane tasks also, and the mundane is actually the word. Sometimes you have to do the trivial tasks. And this is a motor controller circuit for an old vacuum cleaner. It's this vacuum cleaner that's meant to be mounted inside your house with the tubes and stuffs running all over the place. And there are some leads here that is coming from the hose that is controlling this. There are some leads here to the motor and so on. And the guy come to me first with this and complained that the relay was bad. And I changed the relay, and at the time I thought that it was strange that this relay should get this kind of warm. And normally when a relay gets warm, it's because of the contacts is not drawn firmly enough towards each other with enough force. So there are some vibration or might some other things in these springs. And this card, it's just really simple. You have a transformer, you do have a fuse, 250 volt and 8 amps, and you do have this is just a contact, a plug, and you have the relay and you have the switches, and then you have this small card here. And this card contains a rectifier bridge. You have a small PTC, maybe that acts like a fuse or something, I'm not sure what it's doing here. You have a small capacitor and you have 2 larger capacitors. You have 3 transistors. I'll check at once what these are kind of transistors. I do suppose that they are okay. Yeah, it's NPN transistors, and all of them are the same. I can't make out what they really say here, but it's marked with MPSA 06 something and some other number on top or OUG, I don't sure, but it's MPS A06 I think. And you have these diodes here in the rectifier bridge. I'm just testing this with my diode tester in my Fluke. This is probably a Zener diode. It measures okay in this direction, but I don't know if it actually is a Zener diode, but I do think it is. But there is no... There should have been a more heavy resistor in series with this. We do have some resistors here. Yeah, it's a 2K, and this should be a 3.9K, and this should be 15 ohms. The color coding, yeah, and it's also about right. And the PTC is not shorted. Yeah, it tells you about 20 ohms. So every one of these components, and of course there are some resistor networks. I wonder what that is used for. They have used this in conjunction with, and they have some in series here. So these resistor networks is use some kind of creative way of doing resistors. To see what the writing is here. 8X203. I wonder if it means that they are 20K. Let's see if I can find someone that is open here and measure them. Yeah, I do think they are 20K because they are measuring like, yeah. I don't think these are broken. I can of course measure out every one of them to make sure. Yeah, and they're both the same. So everything of these is okay. That mainly leaves us with three components. This small capacitor, and you have this larger, and you have this small 10 microfarad 63 volt, and you have this 220 microfarad 50 volt. So I will desolder this one to just to check if they are okay. Yeah, this is not sucking the solder very well. These legs are also bent over here. Like so. I ripped one leg out of this capacitor, but that of course could have been the problem all along, but that makes it quite impossible to test this if anything is broken afterwards. I wonder if these capacitors has been leaking, because this solder seems really off. It should not be very hard to melt this, but it actually is. So I do wonder if these capacitors has been leaking. It doesn't seem like they have. But this one, if you use your imagination, you can see that it's slightly bulged. So I'm just going to replace these two and see what happens. Yeah, so I just replaced these capacitors. The big one, the 220 nanofarad with Wurt brand, and the other one, I do think I used some China part, but I did measure them before I put them in, and I just sent the card back. I didn't test it, I didn't have the vacuum cleaner here. Of course, I could have analyzed this and connected it, but I didn't. So I left it to the owner to test it, but he came back with this just after a short while and said that it was working for a very short time and then it quit working. I do have these clamps here that probably will, they will be able to fit like so through this and make a good connection without shorting out anything. Yeah, like so. But I do need to keep this way, of course. Yeah, let's follow the power in here. This is L1, and it goes here to the fuse and to the motor, and this is the relay contacts that is shorting in, and this is the short circuit. So the motor out is here, so this is followed just through the fuse, and this one here, this is L2. Oh, that was not a good sign. I really wanted this to keep. Yeah, and this is the other motor. And what's controlling the relay? You have here one line of the transformer, second line to the transformer. So this transformer, this is the output, and this should be always on. And this transformer here, it says that it should be given out 24 volts secondary, and it's 2 volt amps. Yes, but what about this volt ampere thingy? What we do know, that is a 24 volt transformer, and that is marked with 2 VA, or volt amperes as is normally called. And volt ampere is watt, if you don't consider that the sine wave of an AC voltage is complicating matters. So actually the difference is that watt is volt times ampere times cosinus phi for the frequency of the signal. And from this transformer we have stated, if we make this quite simple and don't take this into account, we do have 80 milliamps. 2 volt amps divided by 24 volt is about 0.8 amps, 80 milliamps. And if we consider, is this enough to draw this relay? And we can see here, this is from the data sheet. And this relay here that we are using is an Omron G2R. And we have the 24 volt version. And if we look into this, we see that it's rated with a current of 21 milliamps. And if we check this here, it will be 1100 ohms, the coil that is stated. And this is stated with 50 and 60 hertz. And if we take this and just calculate this as DC voltage, we will get 24 volt times 1100 ohms and 22 milliamps. So we have an 80 milliamp transformer that is driving a coil that is stated for 22 milliamps to make a good enough draw in this. And that means that we have, more than 50 milliamps to do the rest of the circuit. So this should be good enough and well designed. So back to the video. Yeah, but anyway, this is quite easy to measure. Just hook up our fluke here. And since this is 220 volt, I need to make sure that we are not shorting out anything. So I'm going to find two good quality lab leads to hook into the 230 volt outlet. This is what I use when I do use my clamp meter on this. So this is just some short pieces of wire where I have exposed the wires here. And this has the kind of child-proof approach where you do have to, if you put in one it won't work, but if you put both together you will get them in. So you're sure that your kids don't push pins and knitting pins and stuff in here. But that means when I connect this, I do have to connect these to the clamps first, like so, and I need to make sure that these are connected and not getting loose, and I just has to connect this to power, and this circuit should be live, like so, and volt AC. And if I measure from here to here, we do have 238 volt, and I even measure on the output, I have about 39 volt AC. It seems a bit high, but of course 24, yeah, it should not be that high. But if I measure, yeah, it's 238.6, so it's a bit high on the input, but this is a bit higher than I would have anticipated. And this is going into this circuit here on two of these pins. So how was this? You did have the inputs. I'm just going to disconnect this from the mains, and I'm just going to show you one more thing. This one here is the connector that goes in from the hose. So when you turn on your vacuum cleaner, these two are shorted. So a short here should give you some signal over here somewhere. Yeah, we might need to measure from this side, and I'm going to hook this one up. It should be in like so, and I connect this one again. Like so. Now we have live 220 here, not for everyone. Just check that. Yes. And you can see that this here is lighting, and we can check with how much we do have over this capacitor. That should be the main smoothing capacitor. Yeah, it's 43 volt. And I'm going to disconnect this again. 43 volt. And what voltage was this cap again? Yeah, it was 63 volt, so it should keep just fine. But then I know I do have this voltage in here. And what we was going to measure next was actually what kind of voltage we got over this relay. And then I need to put a button or something on these two to be able to turn the relay on and off. So next part is I do need to put up a dummy switch on these ones. I have this one here that I made for something a while back, and it should be perfect. It does have the right kind of contacts here. Yeah, and it's marked here, so this is probably on. So I'm just going to hook that up here, like so. And then if we connect this, remove this one so we don't short anything out. I have not connected the mains on the other end here, but it's better to have good routines so that you don't accidentally do anything wrong. Oh, there the relay was, yeah. So the relay is clicking, and I should be able to measure this if I know what contacts are here, but it's better if I disconnect the power here and just turn this around. So this was not the best clamps. It's the best I have available here right now. But this is what keeps this upright, so yeah, it's better to just do it like so, or maybe I should have something to, I will try to find something. I will just use my old doohickey from way back when. This I made when I was 14 years old, and it kind of looks like it. It's made of solid wood, and it's a vice grip, and I've used it for solder back in the day. So it's not perfect, but this was actually the first time I was touching a welder. So, and this is more than 30 years ago, so I'm not going to complain about the durability. Yeah, but this will keep this straight, and like so, and relay should be off, and measure. Oh, there you will be able to see it. Measure. This is DC. Turn this on, and this should be the relay drossel. It's 26 volt. This really ought to be enough to keep this relay good and drawn, so I can't say why this should making all these sparks. Oh, like so. No, why? 29 volts. This really measures out just fine. But what will happen when we turn this into the vacuum cleaner is that it will start arcing on this relay, and I've actually changed this relay. So this is the second relay that we have on this, and it's just working one time, and then the sparks are eating up this. And there is no kind of noise suppression or anything else on this motor, and the owner says that the motor is running fine when they are shorting over this. And this is actually, as remember, it's shorting over so that the engine will get. And then we can measure what we get. We can take this 220 volt till 230 and measure just like so. I have to turn it on, of course. I'm measuring 9 volts over the relay. That's quite a voltage drop. $242. This fuse does not have a voltage drop, and from here to here it's not a voltage drop. You can see now it's 242. It was actually 239 when we started this, so it's quite a high voltage I have at home here. And now this relay should be drawn, and we are measuring 8 volt drop over the relay. But there are some strange things happening here. If I'm measuring over we have 8 volt, and from here to here measuring over $242, and on the other side 3.9 AC. So this relay is clearly making a lot of resistance. I'm going to take out this relay and I'm going to swap it for another relay and see what happens. Yeah, quite an easy desoldering job this, and I will take and open this relay up. You need to use 2 thin needles or something to put into this to pry this open, but it's really simple and you don't destroy anything with this. But I'm going to try to clean the contacts and see if there is some sparky things on these contacts that is making these huge resistance. This does not feel right. It's a bit wide, I think. This should be harder. So I do a close-up here, and you probably won't see this, but I do think this plastic is a bit melted on these two. So I don't think when this relay is fully activated that it will actually make a good contact. So I do think that we need to change this relay, and probably it melted on the first spark. So this has probably been the second fault after I changed the capacitors. And by second fault, I mean that the relay was defect, but we have accepted the truth that this relay was not a relay fault and that the relay was surviving the capacitor fault, but it apparently was not. And you can see that this is the original relay and this is the replacement, and they now actually have the same fault. So it really is only one solution, and that is I have to change this to another relay. And this time I'm going to change this to a closed relay. The closed relays don't have oxygen in the same way as the others, so if there is a spark, they won't make the same kind of oxidation and stuff. What's happening internally on this, of course, it's impossible to know because this is a closed one. This relay also has the same kind of socket, so it's fitting nicely into the holes of the PCB also. And in fact, I actually ordered this relay at the same time as I ordered the original one that I did replace here, in case there was some, that the one I ordered wasn't the same, but it was actually exactly the same relay that was in there originally. So this yellow one, or orange one, is going to be soldered in. Yeah, I've turned this on. The relay should be drawn, and I'm measuring here over the 28 volt over the relay, And if I turn to alternate current, I will measure from this and to here, 243, and that should be the same as I have over here. So now there is no voltage drop over the relay whatsoever. And I'm just going to test this now with some kind of power draw. I'm not going to put it into the existing motor circuit as of yet. Yeah, I'm going to test this. The power is on, and I'm just going to measure if anything has changed. It has been on now for a while, and we have input 242 and output, yeah, the same, so no voltage drop. I'm going to turn it off, and I'm going to hook up this light bulb. It's not a complete test, of course, but this is a 40 watt light bulb that I use to some testing from time to time, if I didn't break it now then, of course. And I'm just going to try to hook this up. One should be connected over here, like so. And the other one, I will try to hook this up with this. The power is off, so this should be safe. This is not the ideal hookup for this, but if I keep it like so, it should be okay. And the light bulb should start off when I have this switch deactivated. Turn on the power and activate the relay, like so. And the capacitor is keeping the relay a bit, so when I turn this on there is a small delay. Okay, and we measure on the output with the light bulb on, or we can just measure over the contacts and see if there is a voltage drop, and there is 0.02, so almost nothing. And this is with 40 watts. This motor was supposed to have, oh, see the flickering from that light. The motor is supposed to have a 1700 watt power draw. So of course that's much higher, and of course the motor is also an highly inductive load, as there is a huge kind of magnetic field involved in the motor. So what are we going to do from here? I'm going to put this into the vacuum cleaner. I'm going to test it without hooking up the motor, just with the bulb, to check if the inputs here are as they should be through the input filter that we had on the input. Yeah, here's the board, and how this goes. Okay, it's, yeah, they have labeled this 1 and 2, so we just place them the same way as they was. And we have this one, and then I label it 4, this one 3, yeah, like so. And it has to be this one, because this is the output of the relay and motor. And this is actually too short. Marked 1. I have to. This is placed like so, because we had this one that should go on top here like so, and like so, and still is a bit short. This is the one marked 1, but it's input here, L1 from the filter, and the other is 2, so it has to be right. Yeah, just keep it like so, and these two are for the override switch. Like so, and I was going to test this now with the motor disconnected, so that I will see how much voltage actually is supplied here. I can also take this nut here. Yeah, like so. And this, of course, has its own plug. I'm not sure if I can run this without the fuse blowing. I need to test that, of course. And then I mean the fuse in the house, not this one. But of course now I don't have the motor in here, so the purpose here is to measure the output. And of course I can connect my switch here. There actually is power here now, so I have to be careful. And the switch is off. So if I measure here now, might be a bit difficult, but I can measure just here. .242 out of this filter, and I turn this on. Now there should be power from here. No, from here to here. .242. So everything appears to be working. I'm going to connect this one now, and I've turned off the switch. Still connected to mains, like so. And if I flip this switch here now, the vacuum cleaner motor should turn on. And it did. I have to turn this. It was blowing out some dust here. Yeah, that was 2 tests. I am disconnect the motor again. Like so, and I'm just going to measure to see if anything has changed. Turn this on again and measure from here to here, 242. So everything's okay. So I will just give this back to the owner and have him tested with the pipes connected. Yeah. Like so. One old dusty vacuum cleaner saved from the scraps. Yeah, this has been a long one in the making. The first time I got my hands on this vacuum cleaner card thingy was about Christmas time, I think. And it has been lying for a while, and that's mainly because I'm not postponing these things voluntarily, but I hate throwing away things that I know is easily fixed. I think it's a terrible waste, and I also know that if you buy a new vacuum cleaner, it's nowhere near as solid as this. And even that it's 1700 watts make this a huge difference from more modern vacuum cleaners that has much lower power on the engine, and of course they also don't have the same force. Yeah, when there are some dust in the filters and so on. And I take on a lot of these things, and I never say no if I know it's fixable and that I can save the time. But some of these things I have to put on a schedule, and this one I did have to order a higher voltage capacitor, because I don't think that supplying this with from 43 to 44 volt with a 50 volt capacitor, that's not good enough. So I had to wait for a 63 volt part to put into this. And also I'm glad I ordered 2 relays at the same time, because this last relay, it's much better than this thingy here that I still have on my desk. And I will do some repairs like this from time to time, and you can please leave a comment below if you don't wish to see this kind of content on the channel. But I do make a lot of these small repairs, and I do find them kind of interesting from a do-it-yourself perspective. It's unknown territory each time, so I always learn something new. So, hope you enjoyed this video. I have a bit of sore lips, and hope to see you again in my next video. It will probably take a couple of weeks before it's ready, and what the topic will be, I have no idea. I have several videos in the making, but what will be finished first, I don't know. So until next time, please watch some of my older videos and take care. See you in the next one. Thanks for watching.